The question today we are going to do LeetCode 153, find minimum in a rotated sorted array. So we are given that suppose an array length n is sorted in ascending order and it's rotated between 1 and n times, right? So it's just a 1D array and it's rotated fixed number of times and it might become 0, 1, 2, 4, 5, 6, 7. Might become 4. Okay, so essentially this is moved up 4 times, 1, 2, 3, 4, so you expect it to be in the second last position. Yeah, and 1, 2, and then 4, 5, 6. Okay, notice a rotating array one time results in array n minus 1, a0, a1, a2. Yep. So given the rotated array nums of unique elements, we want to return the minimum element of this array, and we want to be writing an algorithm that runs in O log n time. Okay, so we are given a sorted rotated array nums of unique elements. And we want to give the minimum of this array. But we don't know how many times it was rotated. So for example, we are given here 3, 4, 5, 1 and 2, but we don't know that this is rotated 3 times. Okay, and this as well, we're given this array, we don't know that it's rotated 4 times, but however we are supposed to find the minimum nonetheless. And here we know that n is equals to nums.length . Okay, so the maximum times it can be rotated is the size of the array, right? So there is no wrapping around. We don't have to modulo it by n, right? In a case that is rotated more than n times, for example, if it's rotated 8 times, then it's equivalent to rotating the array 1 time. It essentially achieves the same effect. So we're looking at this question and we know that n is equals to nums.length, right? And n can be between 0 to 5,000. Sorry, n is between 1 to 5,000. The length of n. Okay. Yep, and then n is sorted. So this is quite a tricky question. Initially, can't really think about the way we're going to solve this to find the minimum. However, let's just play around with this. We know that we're given an array here, and how about finding the first decreasing element, right? So we have a while loop, while something, right? A while loop, and then if the next element is smaller than the first element, then we know that it's decreasing. So does this work? We have 4, 6, 7, 0. We know that this is decreasing, so we know that this is the point. Something changes. Very tricky. 11, 13, 15, 17, and it was rotated 4 times. Original array was 11, 13, 15, 17, and it was rotated 4 times. It's pretty tough. Can't really think about how we're going to do this. Suppose an array of length n is sorted in ascending order is rotated between 1 and n times. Nums equals to 3, 4, 5, 1, 2. Do we need to construct? Do we need to reconstruct the original array? Unlikely, right? Since we can we find the first decreasing element, right? Using binary search, right? So essentially, we break the array down, right? If we have 3, 4, 1, 5, 2, and then essentially we want to use binary search to check whether the middle element is a decreasing element, right? So how binary search would work in this case is we first find 5 as the middle element, right? And then we check, right? Left equals to 0, right equals to 4, and we have mid here equals to 2. 0, 1, 2, 3, 4. Mid is 2. And then nums mid will be equals to 5, right? And now what we want to do here is we want to make sure that we can get the middle. So nums, if nums mid plus 1, right, is smaller than nums mid, right, then we know that this is decreasing, right? The first decreasing element. Then the pivot is here, so we can return nums mid plus 1, right? So assuming we have this particular example here again, right? And again, right, left equals 0, 1, 2, 3, 4, 5, 6, right is 6, left plus right divided by 2, mid equals to 3, right, and then nums mid equals to 7. No, but this is not a good, this is exactly the same example. Let's try it with this, right? So assuming we have this example here, 3 mid / 2, get a floor operator, floor division, right? So 2, right? What do we do now? We know, if we know that 2 is still increasing, since we know that this is still increasing, we will want to okay. Since we know that nums is sorted in ascending order, the result we want has to be in the right. Could it be in the left? Could it be in the left? So we have 17 here. This could be 19 though. Right? And then this is like an array that was rotated once. This is an ascending array starting from 13, 15, 17, 19 that was rotated once. And if that was only rotated once, and can we immediately find the answer, right? Nums mid equals to nums mid equals to 13. Since we know that nums mid is equals to 13, okay. There are two cases when you find mid, right? The first case is that if nums mid plus 1 is smaller than nums mid, element is decreasing, you return this. Else, if then perhaps in this particular case we cannot throw away, it can be in the left to the right, right? For example, if it's here, we're looking at nums mid is 13, it's bigger, 15 is bigger than 13, right? And here at this point in time we cannot know whether or not 13 is the small, we cannot determine the smallest element from here, right? The only thing we can do is we can conduct search here, we can conduct search here to find for the first element, right? So if nums is mid is greater than nums mid, we have to conduct search again. Search, right? From left to right. You have to search from 0 to mid, right? Inclusive, and search mid inclusive to length of nums minus 1, right? Yeah. And then essentially keep finding the middle element until you realize that one of the element has to be decreasing. The first element that is decreasing. Right? So when you search 0 mid, you essentially get 0 here, you come in here, 0 mid. Let's just try this example. So we have let's try this example here. Right? You search 0 mid here is 1, right? So you search, you get 19 and 13, right? Yeah, and here we got 13. Right? And then for this particular case, we are searching search 1 and 3. Essentially, this would be the answer. Essentially, we want to conduct binary search on each part of the array to find the first decreasing element. Yep, this should be the general idea for this question. Without further ado, let's just hold on. Search mid, length of nums -1, search 1, 3. Is this a recursive solution or is this a iterative solution? Right, that is another question. So now element is decreasing, you return nums mid +1. This nums mid +1 is greater than nums mid. Search this. Okay, so essentially let's just stick it here. Okay, so we have this solution, right? 11, 13, 15, 17, right? So if we have this solution here, right, we essentially break it up, right? The right side would be the same, the left side would be searching mid and 17. 11, 13, 15, 17. So what is the base case here? Can't really figure out if this is a recursive solution or if this is a iterative solution. I think the general idea, I got the general idea of it, but can't really think of the implementation. And see. I think I'm very close, but this is still tough. This is still tough. Log n, right? If we want to do a solution in log n time, essentially the only way we can do it is through binary search, and this idea is correct. But the question is, how do I implement it? If I have nums I is this greater than nums mid, right? We got our answer. This is the key, right? And then what is the alternative, right? The alternative is if nums mid plus 1 is greater than nums mid, so else, right? Else, because they are all unique elements. We know that they're unique elements, so they won't be equal, right? So we have else, and then what we want to do here, search. Essentially, we want to search the left half for any decreasing elements. We want to search the right half for any decreasing elements. Nums mid plus 1 is greater than nums mid, search 0 mid, search mid length. What is my base case? My base case has to be this case whereby what's my base case? Okay, maybe we can return the minimum of 11 and 13, right? We want to return the minimum of 2 elements. No. This. Case 1113. But this base case is 2 elements. No, but what if you have a situation where it's rotated like that, right? Rotated like that, and then your left and right pointer is 3 and 1. It doesn't make sense for me to return. No, it has to be next and next. It's immediately decreasing. I think we almost got it. Let's just... I think I would have failed the interview by this time, but anyway, since we're so close, let's just try implementing this, right? So we have this left, right, okay. Since we round down, the base case is, right, if we IA mid is 0 and 1 or 3 plus 4, right? For example, if we index 3 plus 4, then 3 plus 4 divided by 2. My base case is like that. My mid plus 1 is here, my nums is mid. Nice. Let's do a plus here. Yeah, no idea. Let's just try it. Ridiculous. Yeah, I guess this will be it. Fine minimum. I guess that'll be all for today's video. I will. Looks like I didn't manage to solve this question by myself, and definitely we're looking at the solution. It was definitely pretty close. However, due to time constraint, we have to kind of just find the solution, just Google solution on the site. Yeah. Yep, that will be all. Thank you for watching.